Hello, it's Mr. LaBeouf with another parlor trick. I bet some of you are spending a lot of time with your families lately, and maybe you're getting tired of those marathon Monopoly games. So here's an alternative. Impress your family with this parlor trick. Make sure you do it in the parlor, not in the kitchen. Pick a whole number between 20 and 100. Got it? Add the digits of that number. Now do number 1 minus number 2, the original number minus the sum of the digits. Step 4, add the digits of this new number that you got in step 3. Okay? Pause the video if you need to. Hope I stated it clearly. Well, here you go. You got 9. You can read somebody's mind with this trick. Not really. Let's look at the math. You knew that was coming. In order to understand this parlor trick, you have to be familiar with the divisibility rule for 9. I'm not going to prove that divisibility rule for 9 here. It's not that difficult. But the divisibility rule for 9 is add up the digits of the number. If that sum is divisible by 9, then the original number is divisible by 9. In that way, it works the same as the divisibility rule for 3. The rules are the same. And the fact that 9 is a multiple of 3 has something to do with the fact that those rules are the same, I'm sure. And again, to prove either one of those rules, divisibility rule for 3 or 9, is not that hard. It's probably not typically done in middle school, but if you want to explore it, be my guest. You could probably find a proof for it online, or the next time we have an opportunity, I'll be glad to show you. When we talk about divisibility rules, we also have to keep in mind that if a number, let's say a number is divisible by 9, another way of saying that is that the number is a multiple of 9. So 45 is divisible by 9. 45 is a multiple of 9. That's going to be important when we get to the end of explaining this trick. So we got the divisibility rule for 9. Let's go through the demonstration of this trick with a specific number, and then we'll do it in general. Let's say you chose as your starting number 57, and then you were asked to add the digits, which is 12, and subtract that from the original number. Then you get 45. Now 45 is obviously divisible by 9, and when you add the 4 and the 5, you get 9. Okay? Maybe we'll try another one, and then we'll prove that it works for any number that you choose originally. How about 83? The original number was 83. You're then asked to add the digits and subtract that sum from the original number. 8 plus 3 is 11. 83 minus 11, 72. 7 plus 2 is 9. 72 is a multiple of 9. 72 is divisible by 9. Let's see why it works for any whole number. In order to demonstrate this trick, I have to ask you to ignore the fact that the x and the y are right next to each other, and ordinarily that means multiply. And I hate to do this, but I can't think of another way to do it. I hate to tell you, ignore this thing I've been telling you over and over again, some of you for years, that when you put x next to y, it means x times y. But for this demonstration, this is a 2-digit number. The 10's digit is x and the 1's digit is y. So if we have the number 63, then x equals 6 and y equals 3. And it's not 18, it's just 63. Okay? So this is a 2-digit number. The x is in the tens place and the y is in the ones place. Well, we learn at a very young age that this two-digit number is 10 times x plus y. If it were 63, it would be 10 times 6 plus 3. Place value, right? If this is 63, this x here is not really 6, it's really 60, it's really 10 times 6. Okay? So this is the original number. And then this is the sum of the digits. Remember, the digits were x, y, right? So the sum of those digits is simply x plus y. And then you were asked to subtract the sum of the digits from the original number. Now here comes a very important algebra concept. We want to subtract x plus y from what's above it. You need to subtract both the x and the y. In other words, you can't just put a minus sign in front like that. The minus sign has to apply to both of them. In order to subtract x plus y from a number, you need to do this. You need to do minus x and minus y. Okay, if you are trying to subtract x plus y, you need to think of that x plus y in parentheses and apply the distributive property to the minus sign. This negative sign out here changes the sign of each of these in here and makes it this. Now we can easily subtract. This is the original number, and we are subtracting the sum of the digits. Subtracting the x, subtracting the y. Let's say the sum of the digits was let's say we've got 63, and we want to subtract the sum of the digits, which is 9, right? This, of course, would be 54, and 54 is divisible by 9. It's a multiple of 9. But how else could we have done subtracting 9, 9 being the sum of the 6 and 3? How else could we have done that? Well, we could have done subtract 6, right? And that's 57, and then subtract the 3. Subtract them one at a time, right? If we subtract them one at a time, we get to the 54. Well, that's what we're doing here, subtracting the x, subtracting the y. You might have already finished this, I hope so. Y minus y is 0, and 10x minus x is 9x. 9x, 9 times, it's actually the tens digit of your original number. 9 times a whole number is a multiple of 9. It's divisible by 9, so the sum of the digits in that number is 9. Nice. I hope you enjoyed this. Take care. After you play this parlor trick, start a marathon Monopoly game. I hope you win. Bye-bye.